Good holy everyone. This is EdMath 306, Modern Geometry. My topic is all about. My objective is at the end of the discussion, we should be able to discuss circumcenter or orthocenter and incenter, illustrate circumcenter, orthocenter, and circumcenter. In theorem 4.1 says the perpendicular bisector of the side of a triangle are congruent at the point. It also defined as the point of intersection of the three perpendicular bisector. The theorem 4.1 illustrates in figure 4.1. It says significant when any three lines have common point in geometry because any three lines intersect by pairs to determine three distinct points rather than one point. The proof of 4.1 depends on showing that the point of intersection of the two perpendicular bisector. Let's say the perpendicular bisector of A and C is the line B prime in O, and the perpendicular bisector of A and B is the line C prime in O. Also line lies on the perpendicular bisector of the third sides from C and D is the A prime in O. The point O is the equidistance from A and C because of the perpendicular bisector of them, which is B prime in O. It also equidistance from line A and B because of the line. It is the line perpendicular to it, which is C prime and O. Therefore, O is also equidistance. This is equidistance from line B, C because of it is perpendicular bisector of A prime and O. Since O is the point in a triangle equidistance from three vertices, this is called the circumcenter, the unique circle containing that all three vertices of that triangle. In figure 4.2, let's say the triangle ABC is formed by joining the point of the side of the original triangle. We can see that triangle ABC, which is the midpoint A prime, C prime, and B prime, which is the midpoint of each line, of each side. Since the segment joining the midpoint of the two sides of the triangle are parallel to the third side, the perpendicular bisector of the sides of the triangle ABC are also perpendicular to the side of the triangle A prime, B prime, and C prime. This means that A prime and O is perpendicular also to the line D prime and C, and so on. Thus, the perpendicular bisector of the side of the triangle ABC are the altitude of the triangle A prime, B prime, and C prime. A perpendicular bisector of a triangle in its line drawn perpendicularly from its midpoint. The circumcenter is the center of a triangle's circumcircle, or let me say circumscribed circle. A circumcenter of a triangle is shown in the figure. In other words, we can say that the point of congruency of the bisectors of the three sides of the triangle is referred as a circumcenter of the triangle. Circumcenter of the triangle is located at different uh, triangle. Like for example, circumcenter of the of an acute triangle is located at the triangle inside of the triangle. The circumcenter of the right triangle is at the midpoint of the hypotenuse. Also, the circumcenter of the obtuse triangle is outside the triangle opposite to the obtuse angle. As you can see in the picture, we have different location. In recap, properties of circumcenter of the triangle. We already discussed the circumcenter of the triangle is the center of the circumcenter. Also, all the three vertices of the triangle are equidistant from the circumcenter of the triangle. The circumcenter lies inside the acute angled triangle. The circumcenter lies outside the obtuse angled triangle. Circumcenter of a right triangle lies at the midpoint of the hypotenuse side. Now, the next topic is the orthocenter. It is theorem 4.2 says the attitude of the triangle are congruent at the point. It also the point of intersection of the three heights of the triangle. The point where all the three altitudes of the triangle meet or intersect each other. In figure 4.3 shows triangle ABC in its orthocenter H. The 4 point A, B, C, and H constitute on the orthocentric set of the 4 points. So, named because each of the 4 points is the orthocenter of the triangle formed by the other three. This is the point A, the point B, the point C, and the point H. If you can draw the line where they intersect at H, point H, the point H is the orthocenter of the triangle because it is the point where all the three altitudes of the triangle are intersect. Like this one, the altitude of the angle C is the line A and B, and the altitude of the angle B is the line also the line AD. And therefore the angle A is which is the altitude of the line CF. The point H is the orthocenter of this triangle because of the point where all the three altitude of the triangle intersect. As we can see in the figure, this is the line where they intersect. This is the altitude where the line intersects. The orthocenter of the triangle. The orthocenter of the triangle of the acute lies within the triangle. In a right triangle, the orthocenter coincides with the vertex of the right triangle. In an obtuse triangle, the orthocenter lies outside the triangle. Another recap for the orthocenter. We already discussed the orthocenter of an acute triangle lies inside the triangle. The orthocenter of the obtuse triangle lies outside the triangle. The orthocenter of the right-angled triangle lies on the vertex of the triangle. Incenter. In theorem 4.3 says that this is the internal bisector of the angle of the triangle meet at the point called incenter. It is also the point of intersection of the three-angle bisector. In figure 4.4a, if I is the angle bisector of B, then I, Y, and IX is congruent. Since I is the equidistance from all three sides of the triangle, it is the center of the encircled a circle inscribed in the triangle. This means that the three triangles sides of the triangles are tangent to the incircle. Thus, we say that the incenter of the triangles is the intersection of the three-angle bisector. The incenter is always equidistant from the three sides of the triangle. That's all for today. Thank you.